This is part four. This is the part you've been waiting for. All right. So, this is the electromagnetic spectrum. We are going to talk right now about light waves versus sound waves. Okay. So, sound waves, they travel at roughly 300 meters per second, 600 or 700 miles an hour. You see what I did there? Right here, light travels at 300 million meters per second. So we can remember that light is a million times faster than sound. Needs a medium. Well, what's a medium other than a t shirt? A medium is what the wave travels through. When a sound wave, like a guitar string, gets plucked, when this wave goes through the air, that air is the medium. You've probably remembered when we did in class, I had a glass. The glass was filled with water. I can go through, and if I put a pencil in it, it looks like the pencil bends or it shifts. That's because in this situation, there are different mediums. This would be the air and the water. Right here, the medium is going to be the air that the sound waves are traveling through. Light does not need a medium. So there is a phrase, it talks about not being able to hear explosions in space. The reasons why you can't hear explosions in space is because sound needs a medium. Light does not. No medium required. So if I go through and I play a guitar out in space, if I'm just playing my guitar on the moon, the sound waves aren't going anywhere. There is no way to get the sound to a friend's ear. Now, if I talk using radios, I'm shooting radio waves, these, I can send these through space. So all of these guys, electromagnetic waves, are radiation. They're a combination of light. Sorry, they're a combination of electricity and magnetism. And what's really cool is we can have an electric field. The electric field goes up and down, up and down, up and down. Well, right here, so if that's the electric field, the magnetic field is going to go out and in, out and in, out and in, out and in. So an EM wave, these guys, this electromagnetic spectrum, is the combination of electricity and magnetism. So, right here, gamma rays are the same combination of electricity and magnetism. The only thing that they're different than microwaves would be that they have a higher frequency. So, if I change a gamma ray into an ultraviolet wave, I have to adjust the frequency. Well, what this is showing is we've got visible light. You are a human if you are watching this. Maybe there could be a dog or a cat or a fish watching this. But if you're understanding this, you're a human and it, your eyes can see a specific frequency of light. That's why it's called visible light. So, this visible light can be seen by your eye. And that's because your eyes can adjust to this frequency. Now, it goes through and it says what does it do when it goes through different medium? A light wave is going to speed. Sorry, a light wave slows down when the medium is thicker. So right here, this word is called refraction. Refraction is when light bends. Light bends, and it bends because this medium is thicker than the air. If I go through, and you've probably seen the video of spear fishing, if I have a fish, I have to adjust where I'm aiming my spear because the light actually bends when it goes through a thicker medium. Sound does the same thing. Sound actually speeds up. There was a lab that we did where we clapped hands when we were really close to each other. The sound went really fast. And when the hands were really far apart, the sound went slow. Basically, sound waves go through mediums that are thick or dense really quickly, and light waves slow down when they reach a really thick medium. Thank you. This was part 4.